This is for 8.3.34. Researchers are interested in the effect of a certain nutrient on the growth rate of a plant seedlings. Used hydroponics to using a hydroponics, okay, grow procedure that utilized water containing the nutrient. They planted 6 tomato plants and recorded the heights of each plant 14 days after germination. Those heights, measured in millimeters, were 55.3, 59.7, 61.9. So they gave us how many? They said they planted how many tomato plants? 6 tomato plants. So I have 1, 2, 3, 4, 5, 6. 6 different numbers. They all represent the height, right? So 6 tomato plants in my sample. They want you to complete part A through D below, okay? And notice there's a little button that I can click on. What's that? Oh, okay. So this will take our data straight to StatCrunch. So I'll go ahead and open that right now. Whatever is coming. Oh, awesome. All right. Using technology, find the 95% confidence interval for the population mean. Now, there's only one place to go. If you want to find a 95% confidence interval for population mean, go to stat, go to T-stat. For population mean, you don't know the. Well, this is the one that we have to again use t distribution because we do not know the population standard deviation. So if they'll be able to calculate the sample standard deviation using those 5 numbers. So go to StatCrunch, stat, T-stat, and click on one sample and tell them that you got data this time. So click on with data instead of with summary. I think the last one that we just did was with summary, but this is with data. And just tell them where your data is saved. Data is saved in variable 1, column 1. And what I want is the 95% confidence interval, right? So click on confidence interval for mu. Mu stands for the population average. So what I want is, like, what is the average height for all these tomato plants out there who went through this similar process? And go ahead and click on compute. Here we go. They want you to round to 1 decimal place as needed. So the first number will be 56.9. Round it up. And what's the other number? Hold on a second. Where did my StatCrunch go? The second number is 80.0. Okay, 80.0. 80.0. Now hold on. Did I read it right? No. 68.0. I'm sorry. 68.0. And click check answer. Fantastic. Now what's coming? Name 2 things you could do to get a narrower interval than the one in part A. Choose the correct choice below. So what they want is, maybe somebody may complain, 57 to 68, that's almost like 10 millimeter difference. That's not good enough for me. They want this interval to be smaller. Well, that means you want accurate answer, right? So if you want to be more accurate, your confidence level will go down, right? If you want to be super accurate, like think about the weather problem. I can say I am 100% confident that tomorrow's high temperature will be in between 0 and 100 degrees. Like I am 100% sure. But if I want to narrow down, if I want to narrow this interval, like if I want to say that, well, tomorrow's high temperature will be something in between 70 degrees to 75 degrees. If I want to narrow my interval down, then my confidence level will go down. So decrease the confidence level. What else? Because I see too with B and C are both saying decrease the confidence level. And that's what I just talked about. But what about in terms of sample size? What about in terms of sample size? Now think about it. The more sample you have, the more accurate your sample will be a representative of the population. So it's always better to have a big sample size. It's always good to have a big sample size, and we can connect this with the margin of error formula, which is based on the standard error formula, which happens to be getting divided by the sample size. So the bigger number that you divide by, the small standard error it will be, and the smaller the margin of error it will be. Or in other words, simply saying, if you know more about your population, if you have a big sample size of, like, let's say 1,000 tomato plants, instead of just 5 tomato plants, your estimate will be even better. So if you want to narrow the interval, then you're going to have to probably go down on the confidence level a little bit. But then what else can you do? You can increase the sample size. if you don't want to compromise the confidence level. Okay, using technology, construct 99% confidence interval. Let's do that. Okay, got my StatCrunch open right here. This time I'm just gonna go back and do the same thing. T-stat, one sample with data, but this time you want them to create or construct a 99% confidence interval. So just change the level to 0.99, but we came to the same place. So compute it, ta-da! So the lower bound is 53.7, and we'll talk about how this connects with what we just did on part B. So that's the lower bound, and upper bound is 71.1. Now we went up, you see, from 95%. Let me go ahead and check and see if that's correct, by the way. Okay, that's good. So we went from 95% to 99%. So we increase our confidence level. So if you want to be sure, even more sure, then your confidence interval should get wider so that you can capture, a little more uncertainty, I guess. So if you take a look, the lower used to be 57, now it's down to 53, 54-ish, and upper used to be 67, it went up to like 71. So the interval length kind of got bigger. The interval got wider because, we said, hey, I want to be 99% confident. So it's not as accurate as 95%, but that's what it is. Now, why is a 99% confidence interval wider than 95% confidence interval? Oh, okay. Let's read each of them because they're giving you reasons to read. Okay. All right. The T distribution critical value is larger with higher confidence level. Okay. Okay. So we want to connect it to the T distribution critical value. Now remember how you find the margin of error. You multiply the standard error by this critical T value, right? And as you get further and further out on this T distribution, the T value gets bigger, right? So the critical value will get larger with the higher confidence level. That's true. The T critical value gets smaller. No, that's not true. Standard deviation is smaller for higher confidence level. I think I already got the answer. On a T distribution, the bigger the confidence level is. Like if you want 95%. Now let me go ahead and just show you a quick picture. So if I go ahead and just create a random T, and they didn't say, well, what was the sample size was 5 tomato plants, right? So what if I just change it to a 4 tomato plants? And if I want 95% in the middle. So this will be, guys, this will be the confidence interval, 95% confidence interval, having 95% in the middle, okay? Look, the critical T value is 2.7764 to the right and negative 2.7764 to the left. Now, if I increase the confidence level to what, 99%, then notice, the T value got much bigger. The critical value gets bigger because, the center is still 0. To have more data, to more 99% in the middle, you have to go a little bit out to the extremes, to the right extreme and to the left extreme. That's why if you are going from 95% interval to 99% interval, the interval will get wider because the critical value that we grab from that T distribution gets larger.